Hey, welcome back to your favorite pre-calculus class. This is section 5.7. We're looking at financial models. We're going to determine the future value of a lump sum money, calculate effective rates of return, and determine the present value of lump sum money, and so on. So, if you want to be rich, you will listen to this section. We'll get into the magic of compound interest here in a minute. But let's start out with the simple interest formula. For principal P is borrowed for a period of T years at interest rate R, and that R is going to be as a decimal. The interest I charged is. So for example, simple interest equals principal times rate times time. So a credit union pays 2%. So there's our 0.02 per annum compounded quarterly on a certain savings plan. If $1,000 is deposited, so $1,000, such a plan, the interest is left to accumulate. How much is in the account after 1 year? So let's figure out this interest. Now the time, this thing is 2%, but it is compounding quarterly. So it's just for a fourth of a year. We're going to figure out the interest. It's 2% for every fourth of a year when this thing is compounded quarterly. So if you punch this in, you're going to end up getting $5 in interest. Okay, this is for the quarter one. Okay, so now you're going into quarter two, and you've got a total of, you still got the $1,000, but you also got $5 in interest as well. So now you're going into quarter two with $1,005. You're earning 2% for that fourth of a year, for that quarter. So then you punch that in, and you end up with $5 in this time and 5 cents in interest. $5.05. Okay, so a little bit more interest this time because you started out with a little bit more money. And you keep going with this, so you go into quarter three here. And this time now you have not only the $1,005, you got $5.03 more on that. So now you got $1,010.03 going into the third quarter. And so you get $5.05 this time. And finally, after the fourth quarter, you've got the $1,010.03 plus the $5.05. So you're starting with $1,015.08. 2% for a fourth of a year, and you get $5.08 for that quarter. So after 1 year, you've got a total of, after you got $5, then $5.03, then $5.05, then $5.08. So total, you got $20.16. So what'd you end up with after a year? $1,020.16. Okay. So this is compounding interest. You're leaving your money in there for a certain period of time. You're letting it compound. Okay. So you have a more simple formula that you can use just for that scenario. So the account balance, so how much you end up with at the end. So this is the amount at the end of the time t, is equal to P, the principal amount. So this is the principal, or what you start with, times 1 plus R over N. This is your interest rate. And this also has to be as a decimal. Make sure you punch this in as a decimal. Over N, so this is compoundings, N compoundings per year. Compoundings per year. This is to the NT. Again, the N is the same thing right there. It'll be the same number of compoundings per year. And then finally, the T is the time in years. So T years. Okay. Now the compoundings per year, so that N there, if they say it's annually, then your N would be 1. So if they say semi-annually, your N would be 2. If they say it's quarterly, like that last situation, you could use this equation. Your N would be 4. If they say monthly, this is very common in savings accounts, your N would be 5. Daily, or we go weekly, 52 weeks a year, daily, and so on. That's what your N would be. Okay, so let's do in a scenario. How much money would an 18-year-old student have at the age of 60 if they invested $10,000 in a mutual fund that averaged 10.5% compounding monthly? All right, so how much money would you have at the end? So we're figuring out the A. We're starting with 10,000 bucks. We're putting in 10,000 bucks. Our interest rate is 10.5%. So point, come on, you darn thing. 0.105. 10.5%, again, make sure that's as a decimal. Compounded monthly, so our N is 12. And up here, our N is 12. Well, how many years is that? 60 minus 18, what's that, 42 years? Okay, so you're going to end up with, you got to punch this in. Now, do it inside out, right? Make sure you do the old please excuse my dear Aunt Sally situation. So I'm going to go 0.105 divided by 12, which is 0.00875. Twelve times 42, you get 504. You still got the 10,000 in front here. So now we're going to go 1 plus 0.00875. So we got 1.00875. And then I'm going to take it to the 12 times 42. So I'm going to take it to the 504 now. So to the 504. And I got, and don't cut this off at all. Keep your answer in there. Don't cut this all off until the very end or you're going to have rounding error. So this is 80.7064. Again, I'm going to use this. It keeps going on that. Okay. And then times 10,000. So 807,064 point, now I can round it, 0.149, so 0.15, round it to the nearest hundredth because this is in dollars here, in cents. So $807,064.15, starting with 10,000 bucks and just letting it grow, 10.5%. Let's say you put it in the stock market and you got what it has averaged over the Dow Jones has averaged over the life of its history, 10.5%, 10 to 10.5%. All right. Well, if we take this equation and if we let n get increasingly large, in other words, what this is called in calculus is you say if you run the limit as n goes to infinity on this right here, what you're going to end up with, and this is what this is showing, is n gets bigger and bigger and bigger on that, then what that becomes is it approaches e to the r. So that piece in there becomes e to the r. And this is called a continuous compound formula. So this is only when you are compounding continuously. Now this is theoretical. You're not going to see any banks or anything do this, investments or whatever, have a continuous compounding, but it's a really short and concise formula to do a quick analysis of the money you might have at the end or whatever, or how much you want to start with. So this is, again, only if you're compounding continuously does this apply. So here's a situation. What's the amount that results from investing a principal, so PE to the RT, of $1,000, so we're putting 1,000 bucks in, at an annual rate of 10%, so 0.10 again, for a time of 1 year. So what do you end up with? And notice this is compounding continuously, so continuous compounding, that's why we're using this formula. So we punch it in, and you get $1,105.17. Okay, use that E button on your calculator. what annual rate of interest compounded annually is needed in order to double an investment in 5 years. So now notice we're compounding this time. This is not continuous compounding. We're compounding annually here. So I'm going back to this formula here. Now it's compounded annually, so our n is 1. What's the interest rate? So we're solving for r. What's our r? We're doubling an investment. So whatever we start with p, we got to end up with double it at the end. We're solving for r. We know our n is 1. And we've got to do this in 5 years, so our time is 5 years. So this is what we got to solve. 2p equals p, 1 plus r to the, oops, our n is 1 right here as well. N is 1 there, n is 1 there, to the 5. Okay, so we got to solve this for r. Well, we've got an r and a p, we got 2 variables, but only 1 equation, so this is unsolvable. But luckily, when you divide by p, alright, that'll divide out. You got just this 2 over here. So you got 2 equals 1 plus r to the 5th. So now you just take the 5th root on that of both sides. And that'll become the 5th root of 2. In other words, 2 to the 1/5. Same thing as the 5th root of 2. Equals 1 plus r. Subtract 1 from both sides. So that's what our r is. 2 to the 1/5, or the 5th root of 2, minus the 1. And that'll end up with, let's see if I got it here. There it is. 5th root of 2 minus 1, 0.148698. So in other words, if you round in as a percent, right, round it to the nearest hundred, as rounding that to the nearest hundredth would be 14.87%. All right, move that decimal over twice to get your percent there. Multiply by 100. So to double in 5 years, compounding annually, you gotta get 14.87% on that. How long will it take for an investment to double in value if it earns 5? For an investment to double in value if it earns 5% compounded continuously. So we got EA equals PE to the RT because it's compounding continuously this time. The investment's got to double, so we're going to end up with double the initial amount P. How long will it take? This time we're earning 5%, so our R is 5% here, 0.05, and we're solving for T here. Divide both sides by P, so 2 equals e to the 0.05 t. Undo e by taking the natural log on both sides. So the ln of 2 equals 0.05 t. Divide by 0.05 on both sides. 0.05. And t equals whatever the ln of 2 divided by 0.05 is. And that's our time t. 13.86 years. That's what that ends up being. You could do the same thing if you're going to triple. If you're going to triple the time, put a 3p right there. Triple the amount. How long would it take for you to triple the amount? So you put a 3p in for your amount you're going to end up with. You get the 21.97. You can use these equations to solve for anything, any variable you want, as long as you have enough givens there in the problem. So, all right, we'll see you in class. Thanks for listening.